Alright, this continues section for 6.6, and we are going to graph this linear inequality or solve this linear inequality. Whichever one you say, it's the same exact thing. So the first place I'm going to start here is at my y-intercept, which is 4. So I'm going to put a point here at 0, 4, and then I'm going to use the slope to get 2 more points. So up 1, 2, and over 1, and then I'm going to label that. That's x equals 1, and y equals, if this is 4, I put 2, if that's 4, then this is 2 more up, so it must be 6. So I have 6 there, and then I'm going to come back to my y-intercept. I'm going to go down 1, 2, and I'm going to go back 1, and I'm going to label that ordered pair as well. That's at x equals -1, and y equals +2. And now I'm going to go ahead and I'm going to draw a line. Now you notice that this inequality is greater than or equal to. So what I'm going to be putting on here is the inequality being an included, and so it's going to be at it's going to have equality. It's going to be included in my solution, and I need to make a solid line. So I need to try to locate my line here so that I can draw that. And I missed those points. Let's try it again. So there's that one, and there's that one right there. And I need the right color again. There we go. And let's try it again. I missed it. So you're just going to have to pretend that I hit those lines, and I'm sorry that I didn't. Here's what it really should look like there. So anyway, we have our line there, and now what we want to do is we need to see where are our solutions. So one of the things that we see is that this line, this boundary line, has divided my region into a region above and a region below. So I'm going to pick a point, a checkpoint we'll call it, from that region above, and I'm going to get a checkpoint from the region below as well. Now these are any point above and any point below that will do. I always choose one that's at what I would call a quote-unquote easy point to find the region above or the region below if it's a solution. So easy, by that I mean something that's easy to plug in and simplify. So the origin is always a good point to choose, and I'm going to choose that for my region below because the origin is below this. So this says y, which is 0, is that greater than or equal to, now what I'm doing is I'm checking a solution, right? Equal to 2 times 0 plus 4. And so what I see is 0, is that greater than or equal to 4? And of course this is a false statement. So my checkpoint above, I can choose any point above the line. So I'm going to choose one right here on the y-axis. I'm going to choose 0, 6. So my checkpoint above is 0, 6. Any point will do. And I'm going to plug this in. My y is equal to 6. And I'm asking, is that greater than or equal to 2 times my x, which is 0, plus 4? And what this says is 6 is greater than or equal to 4. And so this is a true checkpoint. That means it's part of the solution. Therefore, I'm going to shade that region. And so I'm going to shade this region above this boundary line. And that is going to form my solution to this. And then lastly, I'm going to put my equation here, my inequality, y is greater than or equal to 2x plus 4. And that's what the solution to a linear inequality in 2 variables looks like. It consists of 1, the boundary line, that's as if this were an equality, and if the boundary line is included, which means it has an equal sign in the inequality, then it's a solid line. If that were to be a strict inequality, a less than or greater than, then it would be dotted. And then we shade a region where all the solutions lie. And we find those solutions by doing checkpoints. We find a point above that line and a point below that line and check them in the original to see if they're a solution, just as we did in our last example. All right.